Since the very first internal combustion engine was created, engineers have continuously strived to make it more compact, efficient, and reliable. Yet one classic problem has always remained: the complexity of its components and operating cycle. Amidst these challenges, an engineer from Kuwait, Dr. Adel K. Al-Subai, a mechanical engineer from Kuwait University, introduced a breakthrough: the rotary vane internal combustion engine, a concept patent pending stage that has the potential to change the way we see internal combustion engines. While piston engines rely on complex crankshafts and Wankel engines still struggle with sealing issues, this design takes a different approach. The intake and compression processes are moved outside the main chamber via an external compressor, leaving only two essential stages inside: combustion and exhaust. As a result, the design becomes simple yet efficient, consisting of a cylindrical housing, an eccentric rotor, spring-loaded radial vanes, and pivoted sealing shoes that maintain tight pressure with minimal wear. This is the core of the rotary vane innovation, a simple concept with extraordinary potential, which we'll explore in more detail in this video. The history of rotary engines dates back to the 19th century, when engineers began searching for alternatives to conventional piston engines. One of the most famous examples is the Wankel engine, which was considered revolutionary at the time for producing rotary power without the reciprocating motion of pistons. However, its main weakness lay in the sealing system. The apex seals couldn't withstand high combustion pressures over long periods, leading to reduced efficiency and increased wear. Many other designs were attempted, from oval and tri-oval housings to complex setups involving additional cams and gears. But the results only made the engines heavier and more complicated, while the sealing issue persisted. This is where the rotary vane internal combustion engine emerges as a fresh solution. With its simple cylindrical housing, eccentric rotor, spring-loaded vanes, and pivoting seal shoes, this design effectively overcomes the classic weaknesses of earlier rotary engines, delivering a level of efficiency and reliability never achieved before. Before understanding how the rotary vane internal combustion engine works, we first need to look at its anatomy. Overall, this engine is far simpler than a piston engine, yet each component serves a critical role. The cylindrical casing is the main housing of the engine. Inside it lies the exhaust groove functions as a staged exhaust release channel, smoothing the gas discharge and thereby eliminating the requirement for a large muffler assembly, even at high rotational speeds. The tangent seal is made of a precision undercut on the casing that matches the rotor radius, designed to maintain a tight sealing clearance. At the center sits the eccentric rotor, slightly offset from the casing's main axis. The rotor is fitted with spring-loaded radial vanes, which are always pushed outward to maintain contact with the casing wall. At the tip of each vane is a pivoted seal shoe, a small mechanism that adapts to chamber pressure, reducing gas leakage to nearly zero, while also minimizing wear. This is where the chamber with varying volumes is formed, the very core of the combustion and expansion process. To keep the pressure between chambers stable, the engine uses a unique sealing system called the tangent seal mechanism. This feature ensures there's no gas leakage between the two zones, the high-pressure side, where combustion occurs, and the low-pressure side, where exhaust gases are released. The tangent seal is alternately achieved by the rotor running within the precision undercut, then be taken over by the shoe hovers over the precision undercut, creating a continuous sealing effect with overlap. This overlapping transition maintains constant pressure throughout rotation, while allowing the sealing shoes to gently pivot along the casing's contour through a tilting seal system. This design not only preserves combustion efficiency, but also significantly extends the lifespan of the components. The engine also features intake and exhaust ports. Unlike conventional engines, the intake supplies high-pressure air delivered from an external compressor, stored and regulated through an air tank, while the exhaust releases combustion gases gradually, ensuring a smoother flow. Finally, all the power is transmitted through the output shaft, which not only drives external applications but also powers the compressor to keep the system running independently. With this straightforward anatomy, the rotary vane engine demonstrates an ingenious blend of mechanical simplicity, efficiency, and practicality. After understanding the anatomy, let's now see how the rotary vane engine actually works. Unlike piston engines that operate on the classic four-stroke cycle, this design follows the principle of positive displacement with pressurized airflow. The first stage is pressurized air intake. Air from the external compressor, stored in the air tank, is channeled into the combustion chamber through the intake port with a one-way valve. Since compression takes place outside the housing, this process is extremely fast and efficient. Next comes fuel injection and ignition. Once the chamber is filled with pressurized air, fuel is precisely sprayed in and ignited by a spark. Combustion pressure rises sharply in an instant. The third stage is power expansion. The high combustion pressure forces the eccentric rotor to rotate, while the spring-loaded vanes and pivoted shoes maintain a perfectly sealed chamber. The thermal energy is converted into rotational energy very smoothly, without harsh jolts, resulting in almost no noticeable vibration. Throughout this process, the tangent seal system actively works to maintain the pressure difference between the combustion side and the exhaust side. Finally, the exhaust stage. As the chamber reaches its maximum volume, the combustion gases are gradually released through the exhaust groove before reaching the exhaust port. This smoother flow significantly reduces vibration, while the gradual pressure release naturally dampens noise, eliminating the need for bulky mufflers as found in conventional engines. Through this simplified cycle, the engine delivers continuous power, high efficiency, and minimal vibration, a combination that is hard to match with conventional engines. Beyond its simple mechanism, the rotary vane internal combustion engine is also highly flexible, as it can be built in different configurations. The number of vanes mounted on the rotor directly affects the engine's characteristics, from efficiency to power output. The triple vane configuration is often considered the most balanced. With 3 active combustion chambers, every 120 degrees of rotor rotation produces a power stroke. The result is a smooth power supply with virtually no vibration, making it ideal for high-power applications, especially for a single casing machine. Moving on to the 2-vane configuration. This setup offers a great balance between simplicity and performance. With a power stroke every 180 degrees, it naturally delivers a higher compression ratio. And since it doesn't require any additional casing for rotational balance, it becomes a smart choice when aiming for high efficiency while keeping the engine compact. The single vane configuration is the simplest mechanically and offers the highest expansion ratio, allowing combustion energy to be extracted almost entirely. However, to maintain smooth rotation with minimal vibration, this design requires 2 or more casings, mounted out of phase to balance each other. Beyond vane count, the engine can also adopt multi-casing setups on a single shaft, or even multi-compressor systems for added flexibility, all mounted on the same output shaft. With these modular options, designers can tailor the engine to different needs, from research prototypes to large-scale industrial applications. In short, the number of vanes gives designers the flexibility to tune the engine for the best efficiency, whether for power, smoothness, or compact packaging. The rotary vane internal combustion engine is not just a new concept. It's a breakthrough that combines simplicity with high efficiency. The energy from combustion is not only used to generate output power, but is also smartly allocated to drive the compressor and offset mechanical losses. As a result, this engine is both more efficient and more flexible than conventional designs. Its main advantages can be summarized as follows. Compact design with minimal components. No crankshaft, no connecting rods, and no complex valve systems are needed. The overall architecture becomes simpler and lighter. Tight sealing. The pivoted shoe and undercut casing maintains stable pressure, improving combustion efficiency. Smooth rotation with low vibration. With no reciprocating motion, power delivery is far smoother. Flexible configurations. From single-vane setups to multi-casing and multi-compressor systems, the design can be tailored to specific application needs. Additional features. Bypass valves allow the compressor to idle, pressure regulators adjust air supply, and certain casings can even switch into standby mode when not required. This engine also features a compressed air kickstart capability, meaning it doesn't require a starter motor at all. In addition, the compression ratio can actively adjust in real time according to operating conditions, offering exceptional flexibility without the need for complex mechanisms. These two features are proof of how a simple design can deliver functional sophistication on par with modern systems. Looking further ahead, this engine also holds remarkable future potential. The concept can be combined with alternative fuels such as hydrogen or biofuels, applied as a range extender for electric vehicles, or optimized with advanced materials like ceramic composites or titanium. With all these advantages, the rotary vane engine is not just an experiment. It is a technology platform ready to pave the way for a new generation of internal combustion engines. Since its invention, the internal combustion engine has always been at the core of engineering innovation. And the rotary vane internal combustion engine designed by Dr. Adel K. Al-Subai proves something simple yet profound. Simplicity can create efficiency, and efficiency opens the path to the future. With its compact design, smart efficiency, and flexible configurations, this engine is not just an alternative. It presents an entirely new vision. From energy-efficient vehicles to precision industrial machines to heavy-lift drones, the possibilities are nearly limitless. Yet what we've seen so far is only the beginning. This technology is still evolving, with potential integration of alternative fuels, hybrid systems, and advanced materials that will make it lighter, stronger, and even more efficient. And behind it all lies decades of experience. Research dating back to 1991 and a series of patents that form its foundation. A true testament that the dedication and vision of a single engineer can open a new era in mechanical engineering.